The dim constellation of Sextans is a celestial monument to astronomer Johannes Hevelius's favorite instrument. By immortalizing it among the stars, the great scientist proved that humanity's thirst for knowledge cannot be destroyed. Today, this celestial instrument hides a spindle galaxy with a colossal supermassive black hole at its very center. And deep within the constellation lurks Hyperion, a grandiose galaxy cluster born at the dawn of time.
Today, let's turn our attention to the celestial sphere, specifically to the quiet equatorial constellation of Sextans. Now, at first glance, it's pretty unassuming, but it holds a really profound lesson. Sometimes the most significant cosmic discoveries are hiding in the sky's quietest, most unremarkable corners. So let's really dive into this paradox. To the naked eye, that vast expanse between the bright constellations of Leo and Hydra, well, it looks pretty empty. But it's this exact lack of bright foreground stars that gives us a completely unobscured window into the deepest, earliest reaches of spacetime. We're about to see how this celestial void is, in fact, a time capsule of cosmic history. First things first, let's get a sense of scale. Before we can appreciate the treasures hidden inside Sextans, we really need to understand just how modest its profile is on the celestial sphere. Context is everything here. You see, Sextans covers just over 313 square degrees of the sky. That makes it the 47th largest of the 88 modern constellations, so it's pretty small. And it's absolutely dwarfed by its neighbors, the sprawling Hydra and the majestic Leo. On a really clear night, you can only make out about 34 of its stars with the naked eye. It truly is a quiet patch of celestial real estate. Okay, now we move from the physical to the historical. Unlike constellations born from ancient myth, Sextans has a documented, tragic, and frankly, a deeply human origin story. It was created back in the Baroque era by the great Polish astronomer Johannes Hevelius. This timeline really traces a story of creation that was born from absolute destruction. You see, Hevelius relied on his large, meticulously crafted sextant for his incredibly precise measurements of star positions. But then, on September 26, 1679, a horrific fire swept through Gdańsk. It consumed his observatory, his home, and his life's work, including that cherished instrument. Years later, in his star atlas Uranographia, which was published after his death, he placed his lost sextant in the sky forever. Hevelius himself captured the raw essence of his loss with this one poignant line. In classical mythology, Vulcan is the god of fire. Urania is the muse of astronomy. So this quote isn't just a lament. It's this profound statement on the conflict between the destructive forces of the world and the enduring human quest for knowledge. And the symbolism of where he placed it, it's just so powerful. This was a deliberate act of intellectual defiance. He positioned his lost instrument, the sextant of Urania, right between Leo and Hydra, two constellations that were traditionally associated with a fiery nature. It's a celestial monument, basically declaring that while fire can destroy an instrument here on Earth, the science it represents is now immortalized among the stars. All right, so from this very human-scale drama, we now pivot to the truly cosmic. You see, the faintness of Sextans, that modesty we talked about, is its greatest asset. It provides an unobstructed line of sight to some of the most massive and distant objects known to astrophysics. And the first thing we encounter is just staggering. Within Sextans lies the galaxy NGC 3115. At its heart is a supermassive black hole with the mass of 1 billion suns. That makes it one of the most massive black holes in our local corner of the universe, a true gravitational leviathan. Now, NG 3115 is also known as the spindle galaxy, and it's classified as a lenticular galaxy. So what does that mean? Well, think of it as a hybrid, in intermediate form. It has a disk and a central bulge like a spiral galaxy, but it doesn't have those distinct spiral arms you see in galaxies like Andromeda or our own Milky Way. And we happen to see it almost perfectly edge-on, which gives it that distinctive spindle-like look. But the spindle galaxy isn't the only thing to see here. Sextans also host a couple of smaller members of our own galactic neighborhood, the local group. These are Sextans A and Sextans B. They're dwarf irregular galaxies about 4.4 million light-years away. And what's really interesting about them is that they're actively forming stars in almost total isolation. This makes them perfect natural laboratories for studying how stars evolve without the messy gravitational interference from larger galaxies. And now we arrive at the most significant discovery within Sextans. We're talking about a structure that fundamentally changes our understanding of cosmic evolution. This is the Hyperion Proto-Supercluster, one of the earliest and most massive structures ever detected. This right here is one of the central questions in all of modern cosmology. How did the smooth, almost uniform early universe evolve into the vast cosmic web of galaxies, clusters, and voids that we see all around us today? Well, Hyperion gives us a direct observational answer. The scale of Hyperion is it's almost impossible to wrap your head around. Its estimated mass is nearly 5 quadrillion times the mass of our Sun. This is a structure of immense gravitational power, and we're seeing it as it existed when the universe was just 2.3 billion years old. What we're seeing here is the process of cosmic dawn in action. The light from Hyperion has traveled for over 11 billion years to reach us. It's located in a region of the sky known as the cosmos field, a specific patch that's been intensely studied for exactly this purpose, to map the distant universe. So we are not seeing Hyperion as it is today. We are looking back in time to the very beginning of structure formation. We're witnessing how vast filaments of dark matter and gas, which were originally seeded by tiny quantum fluctuations, converged under gravity. These created massive nodes, and it was inside these nodes that the very first generations of galaxies began to light up. So let's bring it all back together. We can now unify these two narratives: the personal story of a lost scientific instrument and the cosmic discovery of a nascent universe. The legacy of Hevelius's sextant is so much grander than he ever could have possibly imagined. So what's the takeaway here? Well, for the practical observer, sextants is actually accessible. Just find the bright star Regulus in the constellation Leo and look just below it. With a good pair of binoculars or a small telescope, NGC 3115 will be visible as a faint, elongated smudge of light. But as you're looking, remember the significance. You are peering into the cosmos field, a region that has given us some of our deepest insights into the birth of our own universe. Ultimately, the story of sextants is a powerful testament to the human intellect. An astronomer's personal tragedy, the burning of his life's work, led to the creation of a celestial marker. And billions of years of cosmic evolution placed within that very marker's boundaries, one of the keys to understanding creation itself. It serves as a permanent reminder that the drive to understand is a force capable of transcending any earthly destruction.
Thank you, friends. Strive for understanding and become wiser. See you soon.